Hello, welcome everybody. This is your lesson on 10-2. It is a mini lesson, so these notes will be short and quick, only a few examples to kind of illustrate how to do lesson 10-2 quickly. This information that I'm giving you right now, everything above here, is basically information that is on your note sheet. So central angles are angles in the center of a circle. So for this example right here, that X in the middle would be your central angle. And all of the central angles combined are 360 degrees because that's what a full circle is. Arcs are portions of the circle that walk around the outside. So this would be an arc right here. This would be a minor arc in blue because this arc is less than 180. 180 would be a half turn on a circle. So if I would walk around a circle from one side all the way to the other side, from this edge of the diameter to this edge, that would be 180 degrees. So anything less than this red outside arc would be called a minor arc. And major arcs would be, twisting more than 180 degrees. So for this picture I have drawn, the red arc I'm tracing now would be the major arc. And then you have arc length formulas. Arc length formulas are pretty easy. You just substitute in x. The only question is, well, what is x? X would be your central angle. And you just plug it into this formula. This x over 360, if you're going to do half of a circle, you would have 180 over 360. And then this is essentially like half if you reduced it. So that would be like 50%. So if you went around a circle fully from one end all the way to the other, you would be going in a circumference that would be 2 pi r. So this fraction in the beginning is essentially what percent of the circle, a full circle, you're walking. So you take that percent, which would be like half, and you multiply it by your total circumference. So that's your note sheet summarization. Here are some examples on lesson 10-2, measuring arcs and angles. If I was going to find x, x here is a central angle. I need to figure out its measurement. I have some information already. 40 degrees is this angle, and then you have two right angles there, and I know the total is 360. So basically, I'm going to take 360 degrees, and I'm going to subtract out the portions I know, which are the two 90s, or you could do 180 real fast, and also I'm going to subtract out the 40. So I don't have enough room there for my parenthesis, but basically all I'm going to do is take the full circle and subtract out the pieces that I know added together, and these pieces together would have been 220. So 360 minus 220 would give me 140 degrees. So this x, central angle, is going to be 140 degrees. And then I'll probably put like measure of angle x, kind of getting squished in there, because it's a degree measure, it's a central angle. And then I've already went through arcs. Remember, arcs are going to be a little bit different too. They're the outside walking around, and that is just going to be like a distance when you're talking about an arc, how long this walk is, if this was walking around at a circular like well or something. And arc measures are how many degrees did I walk around, and that arc measure is related to the central angle. More examples, and a couple examples dictate the difference between arc length and arc measure. Arc measure is an angle measure. So when I ask you, angle measure. When I ask you for an arc measure, your answer is always going to be like 30 degrees, or 15 degrees, or 191 degrees. The answer to arc measures are always going to be degrees with a little degree symbol. Arc length, well, it depends on the units you're dealing with, but arc length would be if this was a circular like fountain in the front of a building. How far would I walk if I walked this portion of it? So arc length the answers would be in things like inches, or meters, or centimeters. And once again, you use this formula. This formula comes from a proportion of the circle, a portion of the circle, but I would probably use this one on your note sheet. So if I was going to find the arc length, and this is how you list an arc, you put a little arc above it. So if I was going to do arc DA, it would look like that, with a little arc like that. And if I wanted to find the arc length, and this is kind of weird because arc length is usually denoted by the letter L for length. That's just general formula, so I guess I'll use L to keep everything the same. So if I was going to find the arc length of DA, it would be just plug into this formula. 140 divided by 360 times 2 pi r. So that'd be times 2 pi, and then r in this case is 6 centimeters. So my answer is going to be in centimeters. And when I work all of this math out, you can just plug this into your calculator. So in my calculator, I'd enter 140 times 2 times 6, because these are all the tops. This would be like over 1, so that'd be the top. I wouldn't plug in pi. I'd leave my answer in terms of pi, but I'll show you at the end how to change that to a decimal in a second. So 140 times 2 times 6 is going to be, I believe, 1,680. And you can divide that by 360. Now you do have a pi here, and I didn't put that in there, so I'll put the pi. Now your calculators should be able to reduce that by using the ABC key, so that ends up to be 14/3 pi. Now if you put in the pi button, you certainly could do that and multiply 14/3 times 3.14159, etc. You'll get 14.66. You'll have to read the question. Sometimes I ask for exact answers, would be this blue circle, and sometimes I ask for approximated decimals to the nearest hundredth. That would be this red circle. So I'll do B really quickly. It's pretty much the same thing. It's going to be what, first of all, DA. We need to figure out DA. Oh, here's DA right there. So I need to figure out that degree measure here. So I know that this from here to here is going to be 180 degrees, and this is 28. So basically I do 180 plus 28 to get how much is not included, and that's going to be 208. And then I basically take 360, because that's a full circle, minus 208, and I get 152. So the portion I'm looking for, I'll put it in blue here, this portion right there, whoops. This portion right here, the portion I'm looking for is 152. That will allow me to use my L formula. L equals 152 divided by 360 times 2 times pi, and then r, in this case, be careful, it's 5. The diameter is 10, but you need to cut that in half. That's a 3. And this will all simplify to 1520 over 360, and I can reduce that to 38/9 pi. Okay, 38/9, and before it being reduced, it was like 1520 over 360, and of course, plugging that into my calculator would give me 13.26. So work on reducing these things. They're going to be a nightmare without a calculator that reduces fractions, so I would really recommend you have one of those or figure out how to reduce those pretty efficiently. That's all. Thanks for listening. Have a good day.